So biomolecules in the sense, we know that it deals with the molecules in our body which is related to the life system, right? So here we are going to see about these four things mainly, that is lipids, nucleic acids, carbohydrates and proteins. So much more things will be there, but these things are predominant, right? First of all, what we call it as biomolecules. All the things are involved in some biological aspect. Then how we can differentiate these biomolecules? The word biomolecules came from biochemistry. Do you remember what is by biochemistry? Biochemistry. That is chemistry of molecules which are in a biosystem. That are called biochemistry, right? Yes, let me get into this. Biochemistry is nothing but the study of what goes on within the living system, right? Which, what happens, what is in our living system. So that is the study of biochemistry. And here, this biochemistry is broadly divided into two categories: bioorganic and bioinorganic. Inorganic of less importance. We need not to worry about that much more. And bioorganic, what we are going to study in detail. So in this bioorganic, our focus is based on molecules. That is, we call it as biomolecules. Got this point? So here we are going to focus on these molecules, that is organic molecules, which is related to biology. So that is called a, now in these biomolecules, especially we are going to deal about carbohydrates, proteins and nucleic acids, right? Proteins and lipids, that comes under the same thing. So carbohydrates, proteins and nucleic acids are most important for us. Apart from that, we are going to study much more things, but these things are most important to us, right? Under the topic biomolecules. Other things what we are going to study is lipids, vitamins and hormones, right? The hormone is a newly introduced part of the last year, so that there is a possibility of any 1 mark from this hormones, right? Just mark it as important because it's newly introduced part. Okay. So these things we are going to study, but anyhow, we are going to give importance to carbohydrates, proteins, nucleic acid. This is a prime focus. What do you mean by carbohydrates? Carbohydrates. It is carbon plus hydrogen, right? Carbon plus hydrogen. The molecules which are having carbon and hydrogen, we can call it as carbohydrates, right? You can call it as carbohydrates. Okay. Now, the general molecular formula for carbohydrate is CXH2Y. Let us have this general formula. So this is a formula, general formula for carbohydrate. Right, let us take a well-known example for us. Glucose, C6H12O6, right? So this is a well-known carbohydrate, glucose, right? So this can be written as C6H2O6. That is in the format CXH2OY, right? So this is a carbohydrate which can be written as the hydrates of carbon. You know that copper sulfate is CuSO4, right? When water molecule is added, we call it as copper sulfate hydrate. If 5 water molecules are there, copper sulfate pentahydrate. Like that, hydrate, and what is it here? Carbon. So carbohydrate. So carbon combines with water molecule, that is hydrate, that is called a carbohydrate. Right. Then let us go for sucrose. Sucrose in the sense C12H22O11, right? This can also be written as C6H2O11, right? So this is the same formula as this. So it is of CxH2OY, which is defined as a general molecular formula for carbohydrates. So first we can understand that the compounds which fits into this structural formula shall be called as carbohydrates, right? The compounds which fits into this structural formula, this molecular formula, can be called as a carbohydrate. So the definition for carbohydrate is they are hydrates of carbon. The general molecular formula is CxH2OY. If you take glucose, this can be written as C6H2O6. If you take fructose, it can be written, right? Now, my question is CH3COOH. It is an acidic acid. It also contains only carbon and hydrogen, right? This can be written like C2H2O. How many numbers? Twice, right? So this is also fits to this formula, that is CxH2OY. This is also fits to this formula, right? Shall we call this as carbohydrate? Answer me, guys. Shall we call this as carbohydrate? No. What we can say from here, that is, there are some compounds, even when it fits into the formula, even when it fits into the formula, it cannot be called as carbohydrate. We need a change this definition. What is that? The structures which are obeying this formula, which are that is satisfy this formula, are carbohydrates. So we need a change here. This is not exactly right. We need a change here, right? On the other hand, there are some compounds which behave like carbohydrates, which behaves like carbohydrates, but the formula doesn't fit like this. The formula doesn't fit into the general molecular formula of carbohydrates. Behaves like carbohydrates means what will be behaving here? The PP and CP, the physical property and chemical property of those compounds looks like, shows that, proves that that is a carbohydrate. But when we are looking into the formula, it does not fit into the formula for the carbohydrate. So there are 2 points. That is, one, this one fits into the formula of the carbohydrate but does not have the physical and chemical property of carbohydrate. And here some compounds have the physical and chemical property of carbohydrates but not fits into the formula. So we need a change. Here Ramnos, note it down, this is a 1 mark, important 1 mark. Ramnos doesn't satisfy the formula, but this is a carbohydrate. Carbohydrate. It is a carbohydrate. So there we need a change in the definition of carbohydrate. So this is a final definition we can have. Finally, we can come into a stage that the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones or the compounds which produce such units on hydrolysis, right? Let me clarify here. So carbohydrates, what are the condition? First condition, they should be optically active. Optically active. Optically active in the sense, what should be present there? Chiral carbon should be present there. Optically active means chiral carbon should be present there. And it should be polyhydroxyaldehyde. Polyhydroxy. Polyhydroxy means more than one OH group. Polyhydroxyaldehydes or ketones. Polyhydroxyaldehydes or ketones. Or if it is a compound X, it should hydrolysis. On hydrolysis, it should yield aldehyde or ketone. It should yield aldehyde or ketone. So this is the definition. So now the carbohydrate will be defined as an optically active compound, which is a polyhydroxyaldehyde or ketone, or which produce such units on hydrolysis. So this is a definition for carbohydrates. So the question may be like this: why CH3COH is not considered as a carbohydrate, or why rhamnose is considered as a carbohydrate? Okay, that may be the questions. So we got a new definition for carbohydrates, not only with satisfying the formula CXH2OY doesn't is not a carbohydrate, as well as it should satisfy this definition also. That is a carbohydrate. So this is a modern definition for carbohydrate. It should be polyhydroxy. What is that? Polyhydroxyaldehyde or polyhydroxyketone, or the compounds which upon hydrolysis should yield that one. Right? That's the thing. Okay. Carbohydrate in the sense, glucose is a well-known carbohydrate. Glucose. Right? Okay. This is what I need. Right? So listen here, this is the structure of glucose. Right? D-glucose. So listen here. It is easy to write the structure of glucose. No need to worry about that. First, we have to understand that glucose is nothing but a polyhydroxy aldohexose. That is the name of glucose, right? So remember, it is nothing but it is a hexose. Remember, it is a hexose. So what we have to do, we have to write 6 carbon atoms. 1, 2, 3, 4, 5, 6 carbon atoms in a straight line, and it is an aldohexose, right? So there should be an aldehyde group so that we can write a CHO in the first carbon atom, and the last carbon atom will be CH2OH. The second last carbon atom is there. Na? If the OH group is present on right hand side of this carbon atom, remember this carbon atom you have to mark. If OH group is present in right hand side of this carbon atom, this is called D-glucose. From the down, another OH will be on the same side, and rest on the crisscross side. So here H, and here OH, and opposite side, if there is OH, here will be H. If there is H, here will be OH. If there is OH, here will be H. If there is OH, here will be H. Right? So this is the structure of glucose. This is what they had made here. So this is CHO, OHH, 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 HOH, right? So if this is the carbon atom, you should take into account while you are determining the D glucose and L glucose, right? If I draw the mirror image of this one, if I have to draw the mirror image of this one, this is a mirror image of this compound. You can see here from last second carbon atom, the OH group is on left hand side, so that it is called L glucose. So this is called DL naming. DL naming. DL naming in the sense, you can understand the second last carbon atom. If the OH group is on the right hand side means it is called as D glucose, or it can be called as D glucose, or it can be called as L glucose. So what is this D means? Or it can be written as positive sign. It means that it rotates the PPL in the clockwise direction or in the right hand side. Clockwise direction. It rotates the PPL, it rotates the plane polarized light in the clockwise direction, right? So what is by L glucose then? It will rotate the PPL in the anti-clockwise direction. So that is called the minus or L or capital L, right? So these are the D and L glucose. So these are the first member of carbohydrate family, and this is called as a monosaccharide, right? The glucose or fructose is called as a monosaccharide. The plus D glucose, the plus sign indicates the dextrorotatory. As I said, it rotates the light in the clockwise direction, and this OSE indicates sugar, right? Wherever though is maltose, sugar which is obtained from malt, right? Like that. OSE indicate the sugar. Where does the glucose comes from? The photosynthesis in the plant leaf. And what are the external conditions we require? Sunlight, chlorophyll. And chlorophyll is a what type? What is the name I had given for chlorophyll? The D-glucose is interconvertible in starch, glycogen and cellulose. I'll explain you. Listen here. So the glucose is further divided into starch and cellulose. Starch, and cellulose. I think you know that cell wall is made up of cellulose. You might have studied in your lower classes, right? So the cellulose is a framework for the structure of plants because cell wall is made up of this cellulose, right? And the starch that is in plants and seeds, and the D-glucose is also in the form of glycogen. Glycogen, it is a form of starch stored in our body. Glycogen. It is transported through the bloodstream. Because of the reason it's stored in the body, starch is stored in the form of glycogen in the body. It is called as animal starch. It is called as animal starch, and it's stored in the liver, right? Glycogen is stored in the liver. It is called as animal starch. It is used in the case of emergency. So these are the different variations of glucose. Glucose is stored in starch and cellulose in the form of cellulose in plants. It is in plant seeds and foods, and the cellulose are the basic building block or framework of the building block. And in our human body, in animal body, it is stored in the liver and it is transported via blood system, and it is otherwise called as animal starch. Where this glucose are used? Glucose are biopolymers. Remember this word polymers. Glucose is a unit, single unit. For example, glucose is a single unit, right, like this. And polymers means these glucose units, when linked together in numerous number, that is called a polymer. If glucose is a monomer, this chain is called as a polymer. Right, where we are using the glucose, biopolymers of glucose. It is stored in the liver and muscles for long-term use, and that there we have the name glycogen. Just now you had said glycogen. It is stored in the liver in the name of glycogen, and it is stored as potatoes, bread, rice, carbohydrate. What we are taking every day, that is a starch, and the cellulose is used for making paper, which is nothing but money. Whatever the money we are using, that is made up of cellulose only in a paper. That is a carbohydrate, right? And this plays an important role in the economics. Money, and the wood is made up of cellulose, and the wood is used for shelter and cotton. It is not linen, actually cotton, linen, cellulose acetate. So these are the applications of cellulose. Applications. So without these things, we are not able to live. Na? Without money, without shelter, without clothing, it is not possible for us to live. So the cellulose, that is a carbohydrate, is without carbohydrate, nothing is possible. That is what. While studying carbon and compounds in 10th standard, we studied a word versatile in nature. What is versatile in nature? Everywhere it will be, right? So the cellulose is a major thing. Without cellulose nothing is possible, right? Like that, without carbohydrate no energy is possible for us. So these are the places where we are using the glucose or the carbohydrates or the biopolymers. Now we can go for classification of glucose. The glucose can be classified into different types. Classification in the sense the carbohydrates are classified on the basis of first one basis on functional group. Functional group, if there is an aldehyde, it is called as polyhydroxyaldehyde. If there is a ketone, it is called a polyhydroxyketone. So if it is an aldehyde, we call it as glucose. If there is a keto group, we call it as a fructose. That's the main difference. Aldehyde group, we call it as glucose. Keto group, we call it as fructose. That's the first classification. Second classification is based on reducing nature. Reducing nature. Based on this reducing nature, we should call it as reducing sugar, and non-reducing sugar. Third classification is based on sweetness. So first classification is based on a functional group. Second classification is based on reducing or non-reducing sugar. Third classification is based on sweetness, whether sweet or not. And fourth is based on number of carbon atoms. Number of carbon atoms. And fifth classification is based on number of products on hydrolysis. Number of products on hydrolysis. I think up to this only we can go. So we'll stop here. I'll explain this one by one. Meanwhile, the meeting will end soon. Okay. So see, we had seen up to the classification part only. That is based on functional group, based on reducing character, based on sweetness, based on number of carbon atoms, based on number of products on hydrolysis. Right. Based on functional group, it has been divided into aldehyde and ketone. And aldehyde is called as glucose, and ketone is called as fructose. Based on reducing nature, it can be classified as non-reducing sugar and reducing sugar. Reducing sugar in the sense you have to understand monosaccharides. Monosaccharides. Reducing sugar in the sense further it cannot be broken down into two. If it should not undergo hydrolysis. So listen here, this cannot undergo hydrolysis because this is the smallest part. But in the case of sucrose, if it undergo hydrolysis, in the presence of an acid, it can give a glucose and fructose. It gives glucose and fructose. So that is why this is called reducing sugar and this is called non-reducing sugar. And then, yes, glucose, fructose, maltose, lactose, and all monosaccharides. Listen here, the maltose and lactose are not monosaccharides, but even though they are reducing sugars. Glucose is a monosaccharide, fructose is a monosaccharide, and all monosaccharides are reducing sugars. But maltose and lactose are not monosaccharides, but even though they are reducing sugar. And non-reducing sugar, sucrose, you know. Lactose, maltose, and sucrose are disaccharides. I said, nah, lactose and maltose are not monosaccharides, even though they are a non-reducing sugar. And based on the sweetness, it can be classified into sugar and non-sugar. Yeah, we are calling as a saccharide, monosaccharide, disaccharide, polysaccharide means the word saccharide itself comes from Latin word saccharum, which means sugar or sweet in taste. On the basis of number of carbon atoms, it can classified into triose, tetrose, pentose, and hectose. I told you the glucose is aldohexose. What does it mean? It have a aldehyde group as well as 6 carbon atoms. That is called as aldohexose. So totally we have to count the number of carbon atoms including the aldehyde. So that is hexose, right? So if a carbohydrate has 4 carbon atoms and one CHO, here is one carbon atom, now it is so that it is called aldopentose. If it is 5 carbon atom and one C double bond O, it is called as a ketohexose, right? The simple thing is all the carbon atoms should be counted for the number pent, hex, etc. So this is on the basis of carbon atoms. And on the basis of product of hydrolysis, when it is hydrolyzed, what it will give, right? The monosaccharide, you know that it does not undergo hydrolysis. Example, glucose, fructose, and ribose. No doubt, these are all monosaccharides and oligosaccharides that to have 2 to 10 molecules of monosaccharides are joined together that are called oligosaccharides. When hydrolyzed, that will break down into 2 to 10 units. Examples, maltose, sucrose, and maltose. And polysaccharides means more than 10 units. That are all polysaccharides. Starch, cellulose, glycogen are called polysaccharides. Okay, I think this is enough for this day. So we had seen what is glucose, introduction to carbohydrates, and classification. That is enough.